In this lesson, I want to go through holes and hole notes. At the end of this lesson, I'm hoping that you can identify holes by both what they look like and by the notes that identify them. Let's go ahead and get started. We actually have 6 hole notes themselves, or 6 different types of holes. As you can see in this little drawing, number 1 and number 2 actually look identical to each other. You're never going to see them actually look visually any different. Number 3 is a little bit different. 4 has something special going on at the top. 5 has something special at the top, and then 6 is something different altogether. Well, the first thing I like to do is look at what kind of screws actually go into those holes. So I've drawn up 2 screws here. I've got screw A and I've got screw B. What I want to do is take a look at all the holes that would be appropriate for screw A to be able to go into. So screw A would be able to go into this hole. Now, I'm not necessarily concerned about the length right now. I just drew them short so they'd actually fit this picture. So A to be able to go into this hole would be much longer, but it all has to do with these shoulders up here. So I need a hole that has those types of shoulders at the top, and that's what I can see is created by this first one. So I'm going to go ahead and put an A with this first 2. Then I want to think about, will A go into hole number 3? Yes, again, it would have to be a short screw to be able to drop into there, but it's more about the top or the bottom of this and the top of the hole. So A would appropriately go into that style hole, whatever kind of hole it is. Would A go into this one? Actually, it would drop down inside here, and that's what I want. That's the advantage of that hole, is that I actually take the top of the head and drop it below the top surface. I'm going to take a look at this calculator that I have here, and if I flip it over, you can see that type of hole actually in the bottom of it. So it'll drop the head of the screw actually below the top surface of the material. So that's what that hole is designed for. Would A go into number 5? No, this has something different. The shoulders or the top features of this hole don't match up with what we have here. So I did need to go ahead and put an A here. But A will not go into number 5. Then will A go into this one? Ignoring these dotted lines right now, yes, at least up here at the top, I have what I need for A. So A will go into number 6 as well. So A will go into 1 and 2, whatever the difference ends up being between them. A will go into number 3, A goes into number 4, actually drops down inside this cavity or this area here, does not go into number 5, and does go into number 6. Okay, so then we look at B. If it was important that we actually look at the style that's underneath the head of the screw, then I need a hole that gets something like this at the top of it. So it would not go into number 1. Number 2, this doesn't have this style up at the top. It would not go into number 3, it would not go into 4, it would go into number 5. And that's exactly what number 5 is for. It's for specifically this type of screw that has this cone shape on the bottom of the head of the screw. And then it won't fit in number 6. So each one of these holes is something just a little bit different or used for a different style. Okay, so let's start looking at their names. The first one, 1 and 2, actually has 2 names. It's a thru, or abbreviated thru, T-H-R-U. Majority of the time, we're just going to call it thru as T-H-R-U. It has another name as well, which is clearance. So, how do I identify something as a thru or a clearance hole? A thru hole is something that goes all the way from the top through the bottom. Then what is a clearance hole? A clearance hole is a hole that has additional diameter added to it. If I had this 1/2-inch bolt and a 1/2-inch hole, that's not going to fit very well. It's going to be too snug. So if I have a 1/2-inch bolt, then I need to add a little bit. Let's take a look at one of our software packages to see what kind of dimensions get added to it. So if I say that I have a 1/2-inch hole, and it's going to be a clearance, I have 3 different kinds of fits. I can have a normal fit, I can have a close fit, or I can have a loose fit. Let's just look at the normal. So if we know if it's a 1/2-inch bolt, 1/2 inch should be 0.5 in dimension. But if you look down here, it's actually calling it 0.531. So it's adding 31 thousandths of an inch to allow that to have a little bit of play from side to side. And that was on normal. So if I go to close, you can see that it drops that down from .531 to .516, and then if I've got a loose fit, I'm at .547. So it just has to do with allowing the screw to actually fit down into that hole and not rub the walls or be snug with a close fit, a normal, or a loose fit. So that's going to be everything for a through hole and a clearance hole. Now I'm going to go ahead and scoot my page up, because what I now want to do is write the hole note for that kind of hole. So if I was designing this, yes, I would have to tell the manufacturers where it is, but more importantly, I want to focus on just the hole by itself. If I'm going to focus on the hole, there's really two things I need to tell them. I need to tell them how big it is and how deep it is. So the first thing I'm going to do is throw this little symbol on here that's going to stand for diameter. And then I'm going to tell them what the diameter is. So it's a 0.5 inch diameter hole. I now need to tell them how deep that hole goes into the part. Well, because it's a through hole, then I'm just going to put the word through. So that's the hole note, and this is how I identify on a document that I want a through hole. And if it was a clearance hole, it would look the same, except instead of just saying 0.5, it would say something like the 0.513 or something like that. So a through hole is a hole that goes all the way from the top to the bottom. A clearance hole is one that adds a little bit extra to the diameter to allow the screw to have a little bit more play or a little bit more room side to side. Our next hole, which is number 3, is what we call a blind hole. A blind hole is identified as any hole that does not actually go all the way through the part. So it really doesn't matter this cone shape that ends up being on the bottom of it, that's all fine. That just happens to be done by the drill bit that we're actually going to use. So when I use a drill bit, it has a cone shape on the end of it. The reason you don't see that cone shape on the rest is because they're all throughs. They don't have to be. I could have a blind number 4, I could have a blind number 5, I could have a blind number 6. So they don't all have to go all the way through. It just happens to be our other 3 examples will go all the way through. As far as that goes, the others could also be clearance holes. I could have a number 3, 4, 5 that have some type of clearance added to them. Number 6 is a little bit different. If we add a clearance to number 6, it just gets added into the note just a little bit differently. Okay, so let's think about the hole note for a blind hole. What would the manufacturer need to know to be able to produce this hole other than its location? They would still need to know its diameter and its depth, and this time, since it's not a through all, we're going to replace the word through with something a little bit different. That little symbol says from the top surface down, we would like for that hole to go in, and I'm going to just make up a number. I'm going to say we want to go 1/4 inch, so that's from the top surface of the part to this portion of the hole. I have to go actually additional. If the hole is supposed to be 0.25, then I need to make sure I actually have 0.25 as the hole itself. So that's a blind hole. Any hole that doesn't go all the way through the part, it gets identified with a diameter and it gets identified with a depth. Our next 3 are really kind of specialty holes. The first 2, 4 and 5, actually have something to do with the top of them. So our first one is actually a counterbore. A counterbore has a cylindrical recess around the hole at the surface. It's often used to receive the head of a bolt, or if on the other side, the nut of the bolt. It has to get identified with a lot more information because there's more stuff here. The first thing I always want to identify is the actual hole itself, and it's going to be identified in the same way. So it's going to be identified as a diameter and through, or a diameter and a depth, depending on whether it's a counterbore that's through or a counterbore that's blind. The one that I've drawn right now is a counterbore that's through, so I would go ahead and put on a diameter, identify the number to use for the diameter, and then I'm going to go ahead and put on the word through. Remember that doesn't have to say the word through, it could have the depth symbol and a distance. So that identifies the actual hole itself. I then want to identify the top of it. So the first thing I'm going to do is actually put this little symbol on here to let them know that it's a counterbore. So a counterbore has a cylinder on the top of it, and that's what that little symbol stands for. I now need to go ahead and put on another diameter, that talks about the distance between here and here, so just up at the top. So it's going to have to be larger than the last one. And then it can't be through, it has to have a depth. So that's everything that I would need to give the manufacturer to identify a counter bore. It has a 1/2 inch diameter through hole, so from side to side of the main hole. It then has a top, this is a counter bore, that has 0.75 in its diameter, and it goes down 1/4 inch. Okay, our next one is a countersink. Same thing, we started off with the actual hole itself. So however big the main hole is, and whether it's blind or whether it's through, that gets identified. So I'll go ahead and put on my diameter. And then I need to identify what style of hole it is. It has a top that gets that little symbol. That is the symbol for a countersink. I'll then put on its diameter. An X that stands for by in this situation, and then the angle that those two create. 82 degrees is a common. So there is 82 degrees between these two. How deep does it go? Well, you'd have to do some math to figure that out. So it's 82 degrees right now. Wherever it lands into the hole is wherever it lands. If I need that to go deeper, then I would need to increase the diameter at the top. When I increase the diameter at the top and keep that same 82 degrees, then it will make it go down farther. That 82 degrees needs to match whatever the degree is at the bottom of the actual screw itself. And then our last one is a little bit confusing. So I actually have a hole inside a hole. Not like the counterbore. This is actually a hole inside a hole that goes all the way through the entire part. Well, let's zoom in on that and look at it. So how could I have a hole inside a hole? How could I have two different holes in the same thing? Wouldn't it be when I drilled this hole and then drilled the next one? Wouldn't it just take it away? It's a little bit odd because the hole is actually doing this. If you said that's a threaded hole, then you're correct. We have what is considered to be a major diameter, that's the large one, and then a minor diameter, which is the smaller one. So how we identify it is actually as a solid lines on the outside and then dotted lines on the inside to represent the inside of the thread. Okay, so what we need to do is know its name and what its hole note looks like. So its name is tapped, T-A-P-P-E-D, or threaded. So it's a tapped or threaded hole. Its note looks unlike any of the rest of them. So let me go ahead and draw it out first. So that is what a hole note for a tapped or threaded hole would look like. Well, first of all, you may recognize that we don't have the diameter symbol anymore. That's what the first number is, it just doesn't get the little symbol. So in my notes, I'm going to go ahead and put that little symbol with it just to remind me that the fraction is the actual diameter. So I have 1/4 inch from side to side. The -20 is what we call TPI. And TPI stands for threads per inch. If you actually put a ruler on there and measured it within 0 to 1 inch, you would count 20 threads. So that one is a common bolt, so it's a 1/4 20 bolt. The UNC stands for Unified National, so that just means that we're a US style bolt. And then the C stands for coarse. You'll also see something like an F on the end of it, and that would stand for Unified National Fine. So you can either have something like coarse or fine threads. So that's the 6 kinds of bolts that we have, or holes that we have, my fault. So it's either a through hole, a clearance hole, they get identified the same way, a blind hole that has a depth to it that does not go all the way through the part, and then a blind or a through counterbore, a blind or a through countersink, and a blind or a through tapped threaded hole. And that's it. So now what I'd like to do is go ahead and transfer these 5 holes. Yeah, unfortunately I actually only said 5, so we're going to, really 4, we're going to be able to do the through clearance hole, we're going to be able to do the blind hole, the counterboard hole, and the countersink hole. Unfortunately, Onshape will not do a tapped or threaded hole. So I'm going to show you what that looks like in another software package, but I'm not going to have you do that one since Onshape's not it's not possible for Onshape to do that one. So a through or clearance, a blind, a counterbore, and a countersink, and we're going to use these values that are down here to go ahead and identify the holes on our part. Alright, so let's hop over to Onshape. Okay, so the first thing I want you to do is go ahead and make a new folder, and we'll just call it holes. Go ahead and open up that folder, and we're going to create an empty document. This will be our drill block. So the first thing we need is a block to actually put the holes into it, and we're going to do one hole at a time. So I'm going to put a new sketch on the front view. I'll go ahead and square it up, and I'm going to draw a rectangle that's going to be our block. For right now, I think it'll work if we put it as 4 inches wide and 1.5 inches tall. If we need to add more length to it later, we can. So I'll go ahead and finish that sketch. Put an isometric, and I will turn off my work planes. Okay, we're going to extrude the part, and we're going to extrude the part exactly 1 inch. That's going to be important here in a minute that I know that 1 inch. So go ahead and accept that, and then we're going to start with the holes. Okay, we're going to go ahead and put a sketch on the top surface, and I want to draw a line that goes right down the middle. It's part of that 1 inch, why that was so important. This one's going to be important here in a minute. So I'm just going to draw a line that went from orange box to orange box, and it should automatically turn black. Okay, before I leave this sketch, I need to identify where the hole is going to live, and I'm not concerned about exactly where it lives side to side, so I'm going to grab the point tool. It's right next to the capital A, so I grab the point tool, and I'm just going to click somewhere on the part. I'm not worried about where it is side to side right now. We'll just go ahead and place it on there. I can then put it back into 3D and finish the sketch. That point is identified now. It's where the hole is going to go. So I actually have a hole tool. That's one of our 3D features. So I grab hole, you click the point, and now we need to start talking about the hole, or looking at the hole specifically. So let's look at all the boxes that we have. So open up this first one, and it's really talking about the actual hole itself, or really what we know of as the top of it. It's either going to be considered simple, so it has nothing special on the top. It's a counterbore or a countersink. We know our first two should be simple. One of them is going to be a through hole, one of them is going to be blind. So we have a simple through hole that has a 1/2 inch diameter. Then I can see what I've created, and I have created a 1/2 inch hole at some location. I know where it is front to back, just not side to side, and I can go ahead and accept that. So we have created a hole that goes all the way through the part. And yes, I know I could have drawn that with just a circle and extruded that as a remove, but that's going to be a little bit more complicated when it comes to the other ones. So a clearance hole in Onshape would be drawn the exact same way. I would have just gone ahead and changed the diameter of it to something that was a loose fit, a normal fit, or a close fit. Okay, so let's repeat the process. Do a new sketch on the top. Go ahead and draw a line from orange box to orange box, and let's throw another dot. If that's a 1/2 inch, then I want to make sure I come over at least that much so I can put on my next 1/2 inch hole. Put it back into isometric. I'll grab our hole. I'll pick our point. It does have a simple top, but instead of being through this time, it's blind. And you'll see that Onshape then adds you a new window. And if you look at these, it's pretty self-explanatory what these little windows are pointing to. So that's what I want. I want a 1/2 inch hole, and then I want a 1/4 inch down. That's what we put into our notes when we drew our example. So you can now see that I have a hole that has a cone shape on the bottom of it, just like we drew it. So the drill bit has actually created that cone shape on the bottom. Okay, so 2 more to do. New sketch. Look at it from the top. Go ahead and put a line from center or midpoint to midpoint. Let's throw another one on, and let's scoot over a little bit more because this one's got a bigger top. We've got plenty of room to put 2 more holes on there. So I'm going to go ahead and say hole, pick it. This time it's not a simple hole. Our next one, or number 4, is a counterbore. So go ahead and click on counterbore, and then we have a whole bunch of boxes to fill in. So first of all, this is the diameter of the hole itself, so 0.5. We then have the diameter of the counterbore, and if you hover over them, it tells you counterbore diameter. Then the counterbore has a depth of 0.25, and then we have an overall depth, no, not 0.25. So how do I get rid of that? Well, it's accidentally because I have a counterbore blind, and I want a counterbore through, and it'll go all the way through. And there we go. We now have a through counterbore. So if you look at it from the bottom, I can only see 2 holes. That's because one of them is blind. That's also the reason it's called blind. I'll then put on my last sketch, line from midpoint to midpoint. Oops, I forgot to draw the point. So I'm going to go back into sketch 5, and I'm going to add a point about halfway between my counterbore and the end of the part. I'll go ahead and grab my hole tool, pick my center. It's going to change from a counterbore to a countersink. It remembered the last one that I did, so that's why it says through. And then we have a diameter of a 1/2 inch for the main hole. We have a diameter of 3/4 of an inch for the countersink, that's up at the top. And then I have 82 degrees. I'll go ahead and accept that, and I should have my last hole. Now, the last thing I like to do before I actually take my screen capture of this and paste it into the activity is I want to cut the part open, so just to see it the way we drew it. So I'm going to come up here to the top, and I'm going to grab plane. It's a new tool for us. So I'm going to grab plane, and I'm going to pick this front surface, and 1 inch is the default. What I'm going to do is type in half of my block, which my block was 1 inch, so I actually want a 1/2 an inch. I'll then select this black arrow to switch the plane or flip it around, and now it's dead smack in the middle of my part, and that's what I want. I'm going to create a cutting plane dead smack in the middle of my part. I can then highlight it as orange, and I can right click on it and go to section view. I can also do it over here on the side. I can see the plane, I can click on it, I can right click on it, and I can go to section view. And as soon as I do that, it'll actually cut the part open for me so that I can see inside it. So now you can see all those little lines as everywhere our cutting plane touched, just like the one that we drew. So we've got our through or clearance hole, we've got our blind hole, we've got a through counterbore hole, and we have a through countersink hole. So I want to go ahead and show you a threaded hole. So I'm in a different software package. It's very similar to Onshape. I'll go ahead and draw my line just like we did in Onshape, and I'm going to still use a point. I'll finish that sketch, and I'm going to use the hole tool. It'll automatically pick it in this software because that's what it sees as points. And you can see I have a whole bunch. I have simple hole, I've got clearance hole, I've got tapped hole, and then I've also got all the different tops. So I've got counterbore, spot face, which is very similar to a counterbore, and then the countersink. So once I pick a tapped hole, I then start putting in all my specifications. So we needed a 1/4 so I drop the size and I find the 1/4. That just happens to be the default designation is a 1/4, but there's a whole bunch of them. 1/27, 1/40, so that's 40 threads per inch, 56 threads per inch, 27 threads per inch, and so on. So that's how we can do it in this other software, and it'll actually create all of the threads for me. So all I have to do is tell it the diameter of the hole, the designation of it, and then I can accept it just like we do in Onshape. And that's it for holes.